Welcome to GEOG485 585L, Internet Mapping. Module 2.3, Web-Based Mapping Clients. The OpenLayers JavaScript Framework, Part 1. This week we will be providing an introduction of the OpenLayers JavaScript Framework with an overview of the capabilities of the framework, and then a number of demonstrations of the use of the framework for some basic mapping clients. Next week we will have some additional examples that we will go through that cover some more advanced topics for developing web mapping clients based upon the OpenLayers framework. So when we talk about OpenLayers, there are a number of things that differentiate it from the Google Maps API that we covered earlier in the semester. And these capabilities are listed here. One key capability is that OpenLayers is actually designed to support multiple base maps, including Google Maps base maps, Yahoo Maps, Bing, and a version of OpenStreetMap that is automatically accessed through the OpenLayers JavaScript framework. So this is an extension of the ability in any of those other base map frameworks that, in the case of Google, Yahoo, and Bing, are based upon a proprietary and limited JavaScript functionality. OpenLayers can take advantage of the base maps that are provided by those other platforms, but provide the opportunity to build more customized applications on top of those base maps. One thing that must be kept in mind, though, is that you are still subject to the use and licensing agreements of those various base maps. So, in spite of the fact that you may be using OpenLayers to access them, you are still responsible for complying with all of the usage and licensing restrictions that are a part of those base maps that you might include in your application. Another capability of the OpenLayers JavaScript framework is it is designed to be able to interact with a wide variety of map server platforms. So while the base maps are provided through the APIs provided by, say, Google, Yahoo, Bing, or OpenStreetMap, there are some lower level map servers that OpenLayers can also interact with and use as the source for data or map images that are delivered into the OpenLayers framework. Examples of some of these map server platforms include ArcGIS, which includes capabilities for using the ArcGIS REST web service interfaces, and also ArcGIS caches for accessing data that have been pre-processed into an ArcGIS cache for delivery over the internet. The older ArcIMS platform, the predecessor for ArcGIS Server from ESRI, though ESRI has recommended that map developers move to the ArcGIS Server platform for web-based mapping applications, ArcIMS remains in use by some map providers, so this is a platform that you might encounter in the wild. Another map server platform is CAMAP. This is an open source mapping platform that is really designed for pre-processing of map tiles for delivery through either CAMAP-based mapping clients, or in this case, OpenLayers mapping clients that have been configured to communicate using the COMMAP map tiling scheme. So this is an open source mapping platform that can be used to bring map images into your OpenLayers web mapping application. Finally, there is Map Server, formerly known as Minnesota Map Server, which is a broadly used and supported open source mapping server platform that, in addition to its broad use as an open geospatial consortium platform for hosting the OGC services that we've spoken about already, the web map, web feature, and web coverage services, it also has its own templating language and service model for being able to support web mapping clients that use that templating model. So OpenLayers has implemented a set of JavaScript capabilities that allow OpenLayers to access and integrate into a larger mapping application the data services and template-derived products from Map Server. One of the most significant benefits of OpenLayers is its broad support for Open Geospatial Consortium standards and other international standards in terms of data formats that we'll talk about in a few minutes. Key OGC standards that are supported by OpenLayers include Web Map Services, or WMS, that we've already had some fairly extensive experience with, Web Map Tiling Services, or WMTS, something that we haven't really addressed specifically in this class, but is based upon the Web Map Service standard, but also includes a definition of how map tiles and zoom levels can be predefined to allow for more efficient access to pre-generated map tiles, much in the way that Google generates map tiles that are delivered for its map services, allowing for very high performance and very scalable mapping systems. The OGC WMTS provides an open standards-based model for being able to achieve a similar result in terms of pre-processing map tiles using a predefined grid and set of zoom levels to be able to provide essentially static map images instead of having to generate the map images on demand. A process that can be very computationally intensive, and if you're serving many clients very quickly, can place a significant demand on a server. OpenLayers also supports the OGC Web Feature Service standard for retrieval of data objects into an OpenLayers mapping client for client-side processing of the results of those WFS requests. Though in the long run, OpenLayers is looking like it wants to possibly move away from WFS support and instead implement a broader set of file format support capabilities that would include the file formats that are accessible through a web feature service. OpenLayers does implement support for GML, the OGC standard for vector data, features, and their associated attributes. KML, the representation standard that we've previously discussed, that provides a combination of both geometries, external references to resources, and information about how those features or objects should be rendered within a client. And also styled layer descriptors, or SLD, as a way to allow the client to specify how a particular feature that is requested as a part of a web map service should be rendered by the providing server in terms of whether it's colors, transparency, line weight, those types of attributes that might be defined in an SLD and provided as a part of a request to a remote server for a map image. As with Google Maps, OpenLayers also provides a wide variety of control types that the user can interact with and view that provide information about the map environment and provide the user with the capability to modify the map environment based upon their needs. Included in these various control types are navigation controls, which are essentially some underlying capabilities within OpenLayers that allow for the mouse interaction with the map and some of the other sort of foundation capabilities in the system that support some of the other controls, such as the pan control, which allow you to move the active map north, south, east, or west. A zoom control that allows you to zoom in and out of the map, essentially viewing the map area interactively at different scales. An overview control that provides an opportunity to see the larger context within which the current map is being viewed. Scale controls that provide feedback to the user in terms of the current map scale that is being viewed within the mapping application, with an understanding that the scale calculations are only an approximation because they are ultimately based upon assumptions about the resolution of the device that the map is being viewed on. But at least the scale indicators provide a basic representation of the map scale on the system. There are tools for creating and editing features via the web interface. This is particularly helpful when you are creating new vector data sets and you want to provide the users with the ability to actually create or modify the features within those data sets. This is a very powerful feature of OpenLayers that provides some great flexibility in how you can allow the users to define, say, areas of interest, select feature selections, or other capabilities within the system that are related to the user being able to draw an object on the screen and take some action based upon that drawn object. There's the ability to add a gradical to the screen, to the map image, that provides another frame of reference in terms of the broader coordinate reference system and grid that the map is situated within. And there's also a control for allowing the user to select which layers should be visible within the map, and that's known as the layer switcher. So while you can pre-configure your map with a particular set of default map layers, you can provide a layer switcher control to the user that allows the user to then customize what they are seeing within the map through selecting different layers or enabling different layers. And we'll see an example of that in just a few minutes. There is also the ability to actually create custom-styled features with associated attributes using the OpenLayers JavaScript framework. So you can actually programmatically build those features and link attributes to them within OpenLayers, within your web mapping client. And these custom features can be created and edited using the feature creation and editing control that I just finished describing a moment ago. Some of the types of features that can be created include curves, which are essentially open lines, linear rings, which you could think of as polygons, those are closed regions, line strings, which are also linear features consisting of a number of points that are connected to each other but do not close. Multi-line strings, which are features that actually consist of multiple line string objects. Multi-points, which are collections of multiple point geometry objects. Multi-polygons, which, as you might expect, are collections of multiple polygon objects. And then more simple point, polygon, and rectangle geometry objects. These are all geometry objects that can be created completely within the client and used as the basis for a number of other capabilities within the OpenLayers system. So this essentially could allow you to create an interface where users can create new geospatial data, attach attributes to the features they create, and then even save them in a geospatial file format that you can either send to the server or allow the users to download completely within the client interface on the web. As a part of that capability, for both reading features out of existing data sets and also being able to create new data sets based on features that are defined within OpenLayers, there is support for a wide variety of formats, only a sample of which are listed here, including ArcXML, essentially the ESRI representation within XML of data objects, the Atom feed data model, where this is an international standard for being able to provide structured data and information over the internet. GeoRSS, which is another method for being able to essentially create a feed that can be read by other systems over the internet. GPX, or GPS export files, so that you can actually read or upload a GPX file and potentially use it to create a set of geometries within your OpenLayers web mapping application, and likewise create, say, a linear feature within OpenLayers and export it as a GPX file that you might then transfer to a GPS unit for work in the field. KML files as a way to both bring geospatial data into OpenLayers and also as an export format that can be used to write out information that has been generated or captured within OpenLayers. WKT, or well-known text, as another standard-based representation of features and their attributes, and many other formats. This is just a sample of the many formats that are supported by OpenLayers in terms of being able to read and write data for use within the client. Finally, and probably most importantly, OpenLayers is an open source JavaScript framework that at its core is designed around the concept of the availability of the source code and the licensing of the source code in a way that encourages modification, reuse, and redistribution. And because of this, you actually see other systems that are built on top of or based upon the OpenLayers framework. One popular one is the GeoX JavaScript framework, which is a combination of the geospatial capabilities and mapping capabilities of OpenLayers combined with the Ext JavaScript framework that provides a wide variety of other JavaScript tools and functions that vastly streamline the development of web-based applications. So in this case, you actually have essentially the melding of two JavaScript frameworks into a combined framework that allows for the rapid development of new web-based applications that otherwise would have possibly used those frameworks separately. With GeoX, you actually get a combination of the two frameworks in such a way that it is more streamlined for being able to manage the spatial and non-spatial components of the application more transparently within the larger environment. And that's just one example of the benefit of the OpenLayers framework being an open source framework, one that is not limited in terms of the ability to access, reuse, and redistribute the capabilities of the framework itself. There are some very important resources that you need to keep in mind both for learning about the OpenLayers framework and also for providing background information for doing specific activities within the framework. One of the best places you can initially look as you're wanting to learn about the capabilities of OpenLayers are the examples that are provided by the developers of OpenLayers and other contributors to the project. And you can see here that right now there are over 195 OpenLayers examples. And you can just look for particular capabilities within OpenLayers. So if you're wanting to, for example, look at a sample of how to access Google Maps, you can filter the examples, and now you can see that there are actually 50 example files with some reference to Google Maps. In some cases, they may be using the Google Maps base map, but in others, that you may actually be using the additional capabilities of Google Maps. Or if we just type Google, now it is filtered more exactly, and we can see, for example, here's a Google Maps API version 3 example of how you can develop a map client that is using the Google Maps API version 3. And typically there are notes in each of the examples that provide additional cues or clues about how you might effectively implement what is being shown in the example. Another key resource that you will want to look at is the Application Programming Interface API reference, where this is the technical documentation for all of the capabilities of OpenLayers. So for example, if you wanted information about creating new layer objects, you can click on the layer object here on the left in this table of contents, and then click on one of the entries to see the detailed information about that particular object. As you can see, some of the documentation is a little brief and assumes a certain amount of technical knowledge to be able to understand what the documentation is saying. This is one of the reasons why it's most productive, especially as you're learning to work with OpenLayers, to use a combination of the examples that we were just seeing, the materials that are presented in the course textbook, and the documentation that is provided here, where the API documentation is the most complete and represents to the greatest specificity the capabilities of each object and component within OpenLayers. But as you're learning the application, reading the API documentation can be a bit challenging. So I encourage you to use the multiple resources that we have for learning OpenLayers. Again, the examples, the API reference, and the textbook. So now, let's look at some examples as a way to start illustrating the capabilities of the OpenLayers JavaScript framework, providing the baseline information you need for starting to create your own OpenLayers-based maps. What we have here are links to a variety of OpenLayers-based mapping clients that I have created for the class, ranging from a basic mapper to a mapper that includes links and connections to a wide variety of base maps, a number of examples that are making use of different controls and combinations of controls, and then finally an example that uses the move to function to specify the locations of controls within the map interface. We will have some additional examples that we will cover next week as a part of the further definition of how to create features and add them to your map, and how to integrate OGC services into your maps. But this week we will be concentrating on the basics of just creating an overall map and populating it with the different controls and options associated with the map interface. So let's start by looking at a basic mapper. So I'll click on the link here for the basic mapper. And in this case, this is a mapper that is using the OpenLayers API to access the OpenStreetMap base map, which is an open source global geospatial data set that is hosted both by OpenStreetMap but also by a variety of other map data providers. So, as we've done with the other examples that we've looked at in the class, this is our basic map, and you can see that it is interactive. It is the, as we've sometimes called a slippy map, and that you can grab the map and move it around. You can zoom in and out using the zoom control here. You can always go back to the default global view by clicking on this globe in the control. You can also pan using the pan control here. And you can see that there is an attribution that's associated with the layer that is appearing here in the lower right corner of the map. So let's look at the source code for this map so you can see how the JavaScript is written to enable this very basic map. So the 45 lines of HTML code that we see here is all of the source code required to define this map. And you will notice some significant similarities between this JavaScript and the model you use to interact with and create the map objects, and the JavaScript that you used to create your Google Maps maps earlier in the semester. So in this case, we are creating an HTML5 . In this case, we are creating an XHTML document, as you can see here, by this namespace declaration at the top of the document. We have a head block within which we are defining our connections to any external JavaScript code and also any custom code within the application. We have a body element where the map object itself is created and that contains the information that is displayed to the user. And then we have our closing HTML tag for the entire client application. So, just as we did with the Google Maps API, since we are working with a JavaScript framework, we need to include that JavaScript framework in our application, in our web page. And that is done right here with this script line that basically points, in this case, to the OpenLayers JavaScript framework that is hosted by openlayers.org. So we are not using a locally stored JavaScript codebase, but instead we are using the codebase hosted by OpenLayers. Just like in Google Maps, we pointed to the JavaScript code that is hosted by Google. Though in the case of OpenLayers, you could actually make a copy of the OpenLayers JavaScript code and host it on your own server if you preferred to do that. In this case, we will just use the version that is hosted by OpenLayers. We now have our own JavaScript block that we are creating ourselves that is related to the specific characteristics and definition of our map that we want to design in our application. So the first thing that I do as a part of this JavaScript code that I've written is I'm defining a set of global variables in JavaScript. In particular, I'm defining the longitude and latitude and zoom level that I want to use by default in my map. And I'm also defining a map and a layer variable so that they are persistently available throughout my JavaScript application and throughout my web application. We then get to what is really the meat of the JavaScript that we're going to write, the initialization function. And just as with Google Maps, we have to essentially execute our code that creates the map object and links that object to an object within the web page only after the web page has been written. So just like we did with Google Maps, we have a function that we define, and in this case we've called it init, and that function is only executed after the body has finished loading. So you'll see down here in our opening tag for the body of the web page, there's this event and a JavaScript function associated with that event, where when the body has finished loading, that triggers what's called an onload event. And when that event is triggered, the init function is executed, where we have defined that init function up above. And what does this init function do? It does a number of things. First, just as we did in Google Maps, it defines a new map object. And since this is OpenLayers, we're creating a new OpenLayers.map object. And we are attaching that map object to the element in the document object model as a part of the web page that has the ID of map. This is the exact same thing that we did in Google Maps, where we have down within our body this div called map, where the div within the opening tag has an ID of map. That is essentially the container that we are defining in the structure of the page that the JavaScript uses to attach our map as we're defining it. So with this map object defined, we can now start creating new layer objects, where in this case we're only creating a single layer object, where that layer object is specifically an OSM or OpenStreetMap layer object. Where as a part of the definition of this layer object, I am only needing to specify its name. While different layer objects will have different options and attributes associated with them, the default values for the OpenStreetMap layer object meet our needs here, so we just need to give it a name that will be used in any human-readable access points for this layer, including, as we will see later, the layer picker. So, we've created this layer object, and now we're going to add that layer to our map using that simple map.addLayer function, where we specify the variable, in this case layer, that represents that OSM layer object. We specify that variable as the layer that we want to add to our map. We're also defining some additional characteristics of the map as it will be displayed within the web page. In particular, we're setting the center of the map, which includes both where the map should be centered and also the zoom level, where in this case we are needing to explicitly define the coordinates as a longitude-latitude value in the EPSG projection. So we're converting the values that we're providing to EPSG coordinates and then returning that projection object as the definition of the latitude-longitude points that define the center of the map. And then we're also specifying the zoom that we defined up above, remembering that we defined as global variables lon, lat, and zoom up here. The advantage of defining the variables up here is that we don't have to go digging through our JavaScript if we want to change those values. We can simply change those values here and the map will automatically be updated to reflect those values. And that is the end of our JavaScript for this simple map. The additional information that we're providing for this simple client include a very basic style, where in this case we are defining the width and height of the map object, which is this div here. Again, remembering that this hash map is a way to attach a particular style, defined here, to an object with an ID of map. Remembering the basic HTML work that we did a number of weeks ago. So then our body contains the structure of the rest of the page, where in this case it includes a basic header, a basic descriptive paragraph, and our map div, and nothing else. So if we look back at the map, you can see all of that translated into this interactive map that is handled by OpenLayers in terms of defining the behavior and characteristics of this map, where the data in this map are coming from OpenStreetMaps. Given that, let's now look at another mapper that includes more than one base map. And we can view that by clicking on this second link here. Where in many respects this looks the same, except you can see that there is actually a different base map that is being displayed by default as a part of this client. One thing that has been added that was not a part of the previous map is the Layer Selector, which is indicated by this plus button over on the right-hand side of the screen. You can see that I have added a number of base layers to the map that you can choose from. So we're looking at the Google physical base map now, but I can choose Google Streets, the hybrid Google view that includes the satellite and the road information, or just the pure satellite view. If we want to view Yahoo Maps, we can look at the Yahoo hybrid, or the Yahoo satellite, or street map. Or we can actually look at the Bing roads, hybrid, or aerial imagery. And finally, we can see the original OpenStreetMap that we were working with our original map. So how do we define these additional base maps? Let's view the source for this page. And look at how this script within the head is defined. The first thing you need to notice is that since we are accessing base maps that are provided by external providers, the ability of the client to interact with those external providers is based upon, in many cases, the JavaScript libraries that are hosted by those providers. Where in this case, since we are actually interacting with Yahoo, Bing, and Google, we're actually including some additional JavaScript libraries in our page. And it's because of the loading of these different libraries that we saw that slight delay as the page was initialized, because these JavaScript libraries were being requested from each of the providers. So in addition to the OpenLayers JavaScript framework that we discussed in the previous example, we're also now bringing in the Google Maps API, just as we did when we were developing our own Google Maps applications. And we're bringing in the Yahoo API, where this JavaScript library is required for accessing the Yahoo data. And while Google and Yahoo do not require an API key, Bing does. So I actually have requested and obtained my own API key from Microsoft for Bing Maps, and I've created a variable here where I've written that API key into a variable so that I can use it later when I use the OpenLayers layer object creation function to create a link to the Bing map. So when we get to our custom JavaScript for this page, just like we did before, we have created some global variables, where in this case I'm creating variables for each of the individual layer objects to be created, in addition to our map, longitude, latitude, and zoom variables. So just as we did in the previous example, we now have to develop our initialization function, which I've named init again here, where the first thing I'm doing is creating a new map object, where the creation of this map object is a little bit more involved because I have to create an object that actually is defined with sufficient information that the coordinate reference systems of all of the other external data providers align with the coordinate reference system that is defined for our map. We were lucky in the previous example where the default and simple definition of our map worked well for the OpenStreetMaps. But for the implementation of a map that works across all 4 of these data providers, I need to provide some additional information about the spatial extent of our map, its resolution, the units, and most importantly, the projection and display projection of the map object, where these define the attributes of the map that are used when OpenLayers is composing the requests to each of the map providers using their own native API language. So essentially what OpenLayers has done is created their own middle language, their own way to represent a connection to Google or Yahoo or Bing using their own interface approach and then passing the information in the appropriate way to those remote servers. So with the map now defined, we can start creating our layers, keeping in mind that each layer should have its own unique name. And since I have created these layer variables already up here using these variable commands, I can just refer to them by name down below as I'm creating those layer objects. So when I'm working with Google, I'm creating a new OpenLayers.layer.Google object, giving it a name. So this is the label that appears in that layer picker. So if we go back to the map, you can see there's the Google physical layer here that corresponds with this layer that has been provided this Google physical label as a part of its name. And in this case, we've now provided a layer-specific value where we're setting the type attribute to the value of google.maps.maptypeid.terrain. And if you'll remember, This was actually the value that we needed to define when we created a new map in Google Maps to define what kind of map it was. This is the exact same value that is being passed to Google Maps to define the map type that's going to be associated with this OpenLayers map object that is being created. We're then actually creating 3 more Google Maps layers, each with its own name, each with its own type, and in this case we're also defining the number of zoom levels as another option for the connection to the Google Maps API. You'll remember also that num zoom levels was another attribute that you could set as a part of a Google Maps layer creation. We then need to add those layers to our map to make them available for viewing by the user. And that, again, is using this map.addLayers function. We go through the same process for the Yahoo Maps, where we reference the named variable. We execute this OpenLayers.layer.yahoo function, giving the layer a name, and then providing the values that are needed by that particular layer for communicating with Yahoo's system. And you can see we now have 2 other Yahoo layers, and then here we're adding those layers to the map. Remember that your layers will not appear in the map until you explicitly add them. We're going through the same process for the Bing layers, where the request model here is slightly different in that the structure of the request is a little bit different, but in this case, it's still OpenLayers.layer.bing in this case. And then we are providing the name, the API key that I stored in a variable up above. This is the key that is getting passed to the Microsoft servers so they can keep track of my requests and know that I'm authorized to make them. And then the type of layer being requested. And then 2 more Bing layers being defined here. And then, as with the other layers, executing this map.addLayers function to add those new layers to the map. Finally, as we saw in the first example, we're adding this OpenStreetMaps layer. And then, again, adding that layer to the map. In this case, we're also needing to actually do a coordinate transformation for the latitude and longitude, just as we did for our previous one, for the center point of the map so that it zooms to the proper location. And finally, and we'll see more of this in a couple minutes, we're adding the layer switcher control to the map so that we can choose between the different layers that are within the map. And the rest of the page is essentially the same. We have created our style that defines some basic attributes of the map, and we have our structure defined within the body. So let's talk a little bit about controls. Each map has, by default, a set of controls, and those include the background navigation control, the pan and zoom control, another background argument parser control that allows you to essentially return to a map using a set of arguments provided in the request, and then a control for attribution, where that can display attribution information about particular layers in a map. Those are all automatically added by default unless you explicitly exclude them. So let's start by removing all of the controls from the map as you see here. So you can see actually I can try to scroll, I can try to zoom, and I cannot do it because the controls that even handle the mouse interaction with the map have been removed. This can actually be very handy if you want to include a static map in a document that might be printed where you do not want the controls to appear or you do not want the user to modify the map image that may go into that web-based printed report. So in this case, I have disabled all of the automatic controls and added no new ones. So let's look at the source code for this. And in this case, I have added some new layers, but let's concentrate first on this one line here as we were creating our new map object, where I created a new option for that map object where I set the controls to an empty array of controls. Basically explicitly saying set the controls for this map to none. No controls. That has the effect of suppressing the integration of all of the controls into the map. Just for reference, I have added 3 additional layers, and we'll talk more about adding web map services to OpenLayers maps next week. But that's what I've done here, is I have basically added 3 web map services hosted by USGS to the map. And you will see these layers in the remaining examples for this lecture. But I just wanted you to be aware of these new layers that have been added are coming from web map services that are hosted by USGS. But the primary focus here is on, in this case, the suppression of the controls by including this option as a part of our OpenLayers.map function that creates our map object. And that again produces what is essentially a static map. So now let's look again at the layer switcher. How to specifically add the layer switcher to the map, where we're also now getting the default controls as well. And as I described before, the layer switcher is this control right here. And the one thing I'd like you to notice is that the OpenStreetMap base layer appears with a radio button here. Just as when we saw all of those different base layers, it was a set of radio buttons where you could only choose one at a time. Those additional web map service layers that I added are overlay layers. They are not base maps. And that's why you can actually individually check them on and off and check more than one. So these are key attributes of the layers, but they modify how the layers are presented within the layer switcher control. So how do we add that layer switcher control? Let's view the source here. And there are a number of ways to add controls to a map object. One of the simplest is to just use the map add control function as I've done here, where I have said just map.addControl and then pointed it to this new OpenLayers.control.layerSwitcher function. And all that does is add a layer switcher control to our map object. It's as simple as that. As you start working with larger collections or more controls, you might want to actually organize them into essentially arrays of controls. And we'll talk about that in our next example. Our next example is a control array, where in this case there are a number of controls that we have added to this map, including, in this case, you can see that there's a mouse position indicator, there's a permalink link that you could click on to access a permanent link that represents the current map page. You can see we've still got our layer switcher here, and you can see we have a modified zoom control here and our standard pan control. So let's look at how these have been added to our map. So in contrast to the previous example where I used the map.addControl function of the map object, I'm here defining an array of map controls called, in this case, base controls, and I'm creating a set of controls that are a part of that array by just issuing a series of new OpenLayer.control.control name functions that essentially add each of these controls to this array called base controls. When I create my map, I can then take the controls option and set it to that base control variable, which you will remember is an array of controls. Just as we suppressed the addition of all of the controls by setting this controls attribute to essentially an empty array, here we have populated an array with multiple controls and then included all of those controls through reference of that array of controls when we create our new map object here. So that way you can actually take a collection of controls and add them all at once by just referring to that array. And you can see we still have here at the bottom of our initialization function this add control function from the previous example. So you can mix and match these methods of adding controls to your interface. Another control that you might find useful is an overlay map, which in this case appears by default in the lower right-hand corner and shows essentially the context, the broader context within the current map view. And so if I expand this overlay control or overview control, I can zoom in and you can see that the area within the overview is indicating with the red box the location of my map within a larger context. And as I zoom in, that context changes a little bit. So we're still looking essentially at a global or near global view of the overlay map. But if I zoom in, now we're looking essentially at the southwestern United States, and then the red box is showing the context within the southwestern US. As we zoom in further, you can see that red box is getting smaller. Then as we continue to zoom in, it changes the context within the overlay. So that's the overlay control. So let's take a look at the source on this, where it is very simple in that basically I have manually added that single control with this map.addControl and then new OpenLayers.control.overview map. It's as simple as that to be able to add that control to your map. Finally, another control that you might find useful is a control that displays scale information. And there are actually two controls that you can choose from for representing scale. Where this control here, scale, in this case saying scale equals 1 to 55 million, that's known as a scale control. And here in the lower left corner, this is actually a scale line control. And you can add one or both or neither to your map depending upon the representation that you would like. So if we look at the source on this, we can scroll down and see that I've basically now added these additional two controls using again the same map.addControl function, where in either case I'm then using the OpenLayers.control.scale or OpenLayers.control.scaleLine to add those controls to the map. Finally, you actually have some options as to how the controls are positioned within the map client. And there are two approaches you can use. There's a fairly straightforward approach using the move to function that can be applied to any control object that you've created. And you can also use styles, though that takes a fair amount of sort of dissection of the page to determine what the identifiers of the different objects are so that you can refer to them by their ID or class to effectively apply styles to them that could also modify their position or other attributes of them. Here we're going to concentrate on using the move to function to illustrate the process of modifying the default locations of a couple of controls. And we'll do that by clicking on this last link on the page, where you can see here that I've changed the location of the pan zoom control here and the scale line control. So these are no longer in their default locations. If we view the page source for this, one thing that I've done to make this easier is I'm actually now defining all of my map controls as variables. So these are actually as a part of the global variables that I've defined up above. So in this case, then, each of the controls that I want to work with has a name that I can then refer to later, so I can modify them after they've been created. So in the case of the two controls that I'm going to modify, I have the pan control here that I've just given the variable name pan control, and that is just, as you can see here, a new OpenLayers.control.pan zoom bar. And then I've also created this variable here called scale line control that's just a new OpenLayers.control.scaleLine. I've now created an array for my base controls that I could have also manually added them down below by referring to the variable names. But in this case, I've created this array of controls and I've added them as a part of the map creation command, where I've specified controls as base controls, this array of controls that I created up above. But now I have actually used the move to function for each of the two controls that I'd like to modify the location of, where you specify for each control the pixel location where you would like the upper left corner of that control to appear. So in this case, for the pan control, I'm setting this move to function to a new OpenLayers.pixel value of 650 and 70, where 650 is the X coordinate within the map image, starting at the upper left corner of the map, and 70 is the number of pixels down from the upper left corner of the map. Similarly, for the line control, I am moving that to a location that is 610 pixels from the left edge of the map and 420 pixels down from the top of the map. So in both cases, we are working with coordinates that are within the dimensions of the map, which is why, for this particular example, you might have noticed that in the previous maps I had set the width to 90% of the window size, where that allows the map to dynamically enlarge or shrink depending upon what the width of the window is. In order to be able to effectively position these two controls using the pixel locations that are required by the move to function, I set the width of the map to a fixed value so that I know how wide the map will be, and therefore I know where the controls will be within that fixed sized map. That is something that you will probably also want to do as you start experimenting with moving controls around within the map. Other than that, the structure is the same and the behavior of the map is the same. I've just modified the locations of the default controls and the added controls within the map client. With that, our examples and demonstrations for this week are complete. And as I mentioned before, next week we will work with custom features and the addition of web map services into your OpenLayers maps. Thank you.